Jeff, you want to get started?
We are within 30 seconds. Let's give everybody till just a little bit after the start of the hour, or half hour. Even though we're fully virtual, everybody's partaking of the usual IETF tradition of starting a few minutes late. I see that Ron Chen has joined us. Ron, you're going to be presenting, I believe. If so, could you please test your microphone? And I do not see Dhananjaya or Swadesh, who are the likely presenters for the card documents. Somebody may want to ping them to remind them of the meeting. Okay, we've reached our starting time. Hello, everyone, and welcome to IETF113 for IDR. Reminder, this session is being recorded. And among our other reminders, we are under the IETF Note Well. You have agreed to this as part of your conference registration and are going to be bound to it. A point that is part of the Note Well that we'd like to point out is that the IETF Code of Conduct applies here. So you're requested to be respectful in your conversations with other people. A point that is not made on here that has been called out through the meeting is due to the nature of this being a hybrid conference, we'd like to request that anybody who speaks, please identify yourself. Those who are on Meet Echo, your name will show up in the minutes as a side effect of that. Those of you who are in the room, many of us can't necessarily see you from the small picture, and it will help us as part of doing the minutes. Those of you who are on site, hopefully by this point of the conference, you have downloaded the Meet Echo tool and are capable of putting yourself into the virtual queue. Apparently there's a QR code that you can scan as part of doing this. Please take advantage of that. That will help us with queue management. And there's a pointer to other random information as well. So our agenda for the day is, this is going to be our focused session. We'll go over some slides of what the current status of the working group is. We'll have a track on BGP auto configuration. As part of that, we'll do a quick review of the stuff that's been going on as part of AutoConf. And then we'll have a presentation from Randy Bush on L3ND. We've then reserved about 15 minutes for discussion of auto configuration in general and how we're going to take things forward. We'll have an update on the BGP Yang model by Mahesh. And then we enter the BGP routes with color track. And the first portion of that, we'll be working through the questions summary that we've done as the chairs. And then we'll have a revisit of the two main proposals to date, which is the BGP Color Routing, and then follow that by BGP Classical Transport. We'll then be having a new presentation by Ron Chen on BGP LU. In this case, I think it's supposed to be labeled Colored Unicast. And finally, we'll be reserving the last portion of the meeting for discussion over these topics. If for some reason we actually do have available time, we have two requests for moving some of the presentations from our next time slot up into this meeting, and we'll do so at that time. Since last IETF, we've been relatively quiet on the RFC front. RFC 9184 came out to update how we do BGP extended communities in terms of registration at IANA. We have Auth 48 that's in progress for the BGP open policy stuff. There is a lot of energetic back and forth on the mailing list, dealing with the edge cases there, and this may eventually be a motivation to revisit the RFC 7606 error handling procedures. A issue that will be resolved at a later time as part of more general cleanup is that the original code point allocated for open policy apparently has conflicts with stuff from prior IETF documents that had not formally got them assigned from IANA, and we'll be dealing with that separately. We do have 2 working group last calls that are in the process of being finished. Work is, I think, done. We're just waiting for the Shepherd work to be completed. And this is on the RPD draft for distributing policy into BGP and the related BGP-wide communities stuff, which is actually being leveraged by RPD. We've also completed some adoption calls, and the SRVTN document has been updated. The slide here is slightly out of sync. We do actually have a draft IETF IDR for it. We also adopted the BFD subcode thing, and there's one implementation of that, and are looking for a second one to close out this very minor subcode. We also have several adoption calls in progress, and this is where IDR is certainly, as a large group, is a little distractible at the moment. Side effect of this is that we have a lot of things in flight, not only in terms of our big pieces of work, but also some other ones. FlowSpec v2 is one of those larger items, and we'd like to get that adopted so we can start trying to move that down the pipeline a little bit more energy. We have an adoption call in process for the BGP IFIT capabilities, and there's some interesting discussion around that, and strongly recommend you take a look at the current threads in IDR and also the related IFIT discussions in other working groups. We also have an adoption request in process, partially motivated by some grow work for clarifying procedures for maximum prefixes and how it interacts with the BGP state machine. And as part of a set of work related to the BGP control plane being used for multicast purposes, we have this document for SRP2MP. Please take a look at that and also the related work that is in other working groups, including BESS. You can see on the right-hand side that there's a link to the IDR wiki, and it will help you find the current status of this sort of thing. And we're also trying to keep documents that are clustered together with related work in other working groups in the wiki. We have some adoption calls that will likely be getting kicked off as part of finishing up this IETF work. The BGP classful transport and BGP car are two of the topics to be discussed today, and as part of working through things today, we will hopefully be able to start a working group adoption calls once we figure out what that looks like. And very similarly, we have a set of adoption calls to be done on auto configuration, and we'll discuss those as we move along. We had one no consensus on the VPN prefix ORF. There is a lot of energetic discussion there, and the authors are still very interested in continuing work on this. As discussed on the mailing list, they're encouraged to obtain a first come first serve code point and begin implementation, and perhaps as their work actually bears fruit, we can hopefully see if the working group's willing to reconsider this based on implementation experience. Not a specific working group adoption item, but had generated a lot of energy. We had a lot of discussion on link local next hop capability. I think this one is just mostly a matter of finding a single editor to take point on this and move that forward. And once the chairs have a little bit more bandwidth, we can drive this. But this is a place where if you have the energy to drive this yourself, maybe we can help schedule it that way. We've also had requests for working group attention from several other working groups, including BESS, PCE, Beer, and Cider Ops. Some of this is about working group last call comments as part of AD follow-up. So John Scudder has asked us to help take a look at the color bits, as part of the segment routing TE policy draft. So please chime in on that thread. From BESS, we also have 3 specific documents that need additional focused review: the SRv6 services document, the EVPN IPVPN internet networking draft, and the unequal load balancing draft as well. From Cider Ops, Randy Bush has asked us to take a look at the ROV no RR draft. The short version of that is carefully carefully managing how route refreshes are done when you're running the RPKI router protocol for route origin validation. And PCE also has feedback requested for some of their work as well. Trying to wrap up the status, we attempted to schedule interim meetings, and as we've discovered, both partially from the usual end-of-year scheduling problems and also fun with the pandemic. We made 3 attempts to schedule interims that failed. We did finally manage to have a successful interim with a lot of energetic discussion on January 24th. And the subjects there were largely Bgp routes with color in terms of here's presentations on CAR NCT and some of their properties. We also had relatively quiet presentations at that time on Bgp auto configuration for the LLDP proposal and an update on draft Minto. And unfortunately, at that time, we did not have any progress on FlowSpec v2. And return to our agenda slide, just to sanity check where we're at. So we've entered the discussion for introduction to auto configuration. And then after that, we'll turn it over to Randy for his presentation at L3ND. So for auto configuration, we have several drafts that have been in flight over the course of the work. As you recall, we had a design team that worked through the requirements, and we have a draft that has been published for that. After that work was done, we had 3 proposals on the table in terms of different types of technologies that implement the requirements. After those things had been presented, we had a general plan to start adoption questions and calls after the January interim. We had a last-minute proposal for L3ND, and as part of fairness to the authors, I'm going to make sure that they got equal time for presenting their work, and also to have equal level of scrutiny paid attention to it, similar to what had been done over the last couple of years as part of the design team analysis. So we delayed the adoption call until we can get it presented at this IETF. And we kicked off some discussion about the proposal on IDR mailing list. You're encouraged to take a look at those threads and respond to any questions that may have been raised there. And as a critical point, with L3ND being issued, we now have all of the IDR chairs with an active hand in the solution space for these proposals. This means that adoption and consensus calls are going to be very carefully monitored and given high-level scrutiny. If there's any circumstance where we find that the consensus is unclear, we're going to be involving a third party that's delegated to make those calls. So this is where I pause for a second to see if there's any questions before we begin Randy's presentation on L3ND. And this is the question that we'll be dealing with afterwards. Okay. There being no questions, we'll begin Randy's presentation.
I seem unable to send video, so you will be saved from seeing my face. But you will have to put up with Magenta Comic Sans. Note that this protocol proposal is a 3rd generation. The other 2 generations were actually in the LSVR working group. Jeff, I don't have controls on the slides yet.
Okay, I have not seen the incoming request as you did last time. Here it is. You've been granted permission.
But the other 2 were at layer 2. This is at layer 3. Still waiting for permission. Okay. Okay. Lots of usual suspects. The attempt here is to come up with a stupid, reliable, boring, measurable protocol, not a stochastic exploration because when you've got 10,000 devices, if you're playing with probabilities, 0.001 still loses you a bunch of devices. But so the protocol is rather stiff and boring. It's like the L3DL layer 2 protocol, except this is layer 3. So if you were familiar with L3DL, the payload PDUs will look familiar to you. They still handle very large data. The purpose of that is more for EVPN than BGP discovery. But note that if you don't shove a whole bunch of addresses into a PDU, then it's still small. The only thing with being able to handle very large PDUs is the length fields of the PDUs chew up some bits. It's a multicast UDP hello for initial discovery. It is session-oriented and resumable. So the peers actually have sessions that have a session identifier and can be resumed from checkpoints if things are broken, etc. There is no retransmission because it uses TCP. TCP handles that. The only state that's kept is the minimal state at the ends of what it has learned about the other end. It is not, the protocol itself contains restartability, but not state. Thanks to TCP, it's guaranteed reliable in order, et cetera, et cetera. It also wants to use TLS preferably. Okay, L3DL, by the way, was over layer 2, so it had to provide its custom reliable transport. The object is to find your neighbors, learn their layer 3 addressing, and bootstrap BGP. Okay, so we see at the bottom, the L3MD is exchanging PDUs over TCP or TLS. It learns the information about AFI-SAFIs of its neighbors and then communicates up to BGP. We don't know how it communicates up to BGP. I'll discuss this in the final slide if we survive that long. This is not a routing protocol. It just discovers layer 3 addressing. Okay. Basic PDU TLV 101, except we have a version number in front of it. We have a PDU type for the T, a payload length for the L, and the payload itself for a value. The multicast UDP hello has a flags field which says, hey, I would like to do raw TCP, or I would like to do TLS, please. If it chooses TLS, then you can either use a self-signed cert or a certificate authority-based cert so that a data center can have a X509 certificate structure and things can be strongly authenticated. The port number is thrown in there for a giggle because IANA will have assigned a port, but it's there so the operator can override and do custom ports in their data center. The TLS open, we've seen this, their hello has come in. The sender knew its IP address. The receiver saw the source address on the hello. So each knows the other's address for the interface for the hello. So they can choose who is going to be the TCP server and who's going to be the client by the classic method of the lowest IP address provides the server and the highest is the client. If TLS, was it CA based or self-signed? If it's self-signed, we call it TOFU, trust on first use. I jokingly call that married on first date, because what it is you believe without question who the other is. You do get, of course, integrity checking from TLS. And if you disconnect and reconnect or restart, you know that you have the same peer or the same attacker. So you know their identity is constant, but you have no reason to trust their identity. Whereas if you use a CA, the server certificate has been signed by the X509 structure of the environment. The server used that cert, and the client has the public key for that certificate and can verify it, and therefore knows the identity of the server and trusts it. So we have authenticity, classic TLS. The choices is up to the operator. So we have an active TLS or naked TCP session. We now go to the L3nd Pdus. The first PDU is open. Open has a session ID. As I said, this is a session-oriented protocol, and I didn't just mean the TLS TCP, but the idea of an L3nd session. Okay, and there's a serial number you're going to see in the data PDUs, which allow that if things get broken, they can reconnect, they can reissue an open with the old session ID and the serial number of the last good PDU and say, hey, if you're cool, I'm cool with resuming the session from that point. Now, this is designed much more for the large scale addressing space of EBPN, et cetera, but it's certainly useful in the BGP sets. There's also a list of attributes in the open, which says, hey, I'm a leaf, I'm a spine, I prefer coffee chip ice cream, whatever, they're user defined. Okay. All PDUs are ACT. This is, as I said, a really dumb standard old style protocol. The ACK also acts as an error notice. So if there is an E-type greater than 0, it tells you, hey, this is a warning, the session is broken, or call the operator. And there are room for error codes and hints and so on and so forth. You will be reminded of SMTP and other error codes like that. Okay, as I said, it's fully stateful. There's a session per peer, restartable, and can be resumed. So we now have a session established. I want to tell you what IP, in this case IPv4, address space I have on my device. So note there was the serial number. And then I pass you a list of IPv4 addresses, or we call them for the moment encapsulations. That word has been confusing. We'll work on it. But each IPv4 address has a flag field and then a prefix length, of course. The flags say whether I'm announcing it or withdrawing it. Is this a primary or secondary interface? Is it an underlay or overlay interface? Is it a loopback? Of course, they're similar for IPv6 and to give you some MPLS clue. Okay, so if we have that, I now know what address space my peer has. How do I set up BGP? I want to, this is for configuring arbitrary layer 3 protocols, but so far we'll only discuss BGP. There's what we call an upper layer protocol configuration, PDU in L3ND. There's only one active type we're going to talk about, and that's BGP. And it has a whole bunch of sub-TLDs. For the moment, we'll call them attributes. The goal is to provide the absolute minimal set of configuration parameters for BGP open to take over and succeed. We don't want to conflict with data that might be exchanged in the open because multiple sources of truth are a way for a real mess. So we're not going to tell you things that the BGP open will discover or assert as capabilities, etc. I'm going to tell you my AS. I'm going to tell you what IPv4 peering address I would like to use. And remember, that could be a loopback. And when I told you my addressing, I told you what I'd have marked it as a loopback. You'd have known my primary, so you can set up forwarding. Okay. Blob for authentication, data MD5 or whatever, and also a flag for GTSM. And yes, of course, there is for IPv6. And remember that loopbacks, etc., were marked. So, some people like some of these things, some people don't. That's why we have IDR to discuss things internally. It's stateful and restartable. It's got handshakes, error reporting, all that stuff. It runs over TCP. If you have BGP on your device, you have TCP. If you want security, do you roll your own or just shut up and use TLS? In the security world, roll your own is a long form of you are extremely stupid. L3ND provides large scale, probably more than BGP needs. We can argue that. It really only costs a few bits in the length fields if you don't use the scaling and try to handle over a ton of addresses. And I can go into now or some other time how you can use it for highly scaled EVPN, multi-pod, et cetera, with the whole thing's multi-tenancy, microservices, that whole world. This also serves as a discovery mechanism for that, just because it scales.
So Randy, if I may interrupt.
No, you may not. That's it, except one other thing. I still do not understand how parameters are passed to BGP. Okay. In L3DL, we specified that BGPLS is used to communicate with BGP. How is BGP started? How do you tell BGP, okay, here are your data, you can start now. Oh, data have changed, you need to restart. When is discovery finished? Should it be stopped, or because new people will keep plugging in devices and old devices will leave, do we keep running forever? How's that done? Is there a full-scale orchestration system over that? If so, we haven't really discussed this. Okay. And I really question, do we really need the restartability? It adds complexity. And now I really am through. And Jeff, if you wanted to ask questions.
So I had more questions, but I wanted to take you up on your suggestion to briefly discuss the EVPN scaling, because I think that it ties into some of the motivations potentially for how you're specifying your encapsulations PVU.
Yeah.
Did you want to discuss that or defer that for a different presentation?
I think deferring probably is wise.
Okay. So if that's the case, we now have questions at the microphone. AC, you're first.
AC Lindum, Cisco Systems. Hey, I was just going to say the last part about how this is communicated to BGP. I think that's an internal. We don't have to specify those APIs between the discovery protocols and BGP, or let's say any other entity that wants to learn these things. I really think that's out of scope for the IETF for the standard. That's it.
Martin, you have the microphone.
Hi, Martin Huněk. I would like to ask about the TLS certificates. Did you consider DANE also to validate the TLS certificate?
No. You'll notice there's no DNS here. Putting DNS and BGP in the same bucket sounds like possibly a little asking for complexity. I'm trying to be polite. I am a fan of DANE. I don't want to put DANE down. I just don't think we want to add DNS at this layer.
Okay, thank you very much.
Okay, you're next.
Yeah, I'm just going to speak as a working group member, taking my working group chair hat off. I do agree with you, AC. This is going to be how you actually pass the data to BGP is going to be a matter of implementation details. Thank you.
I don't agree with that because I want interoperability between vendors. And that is one of the core purposes of the IETF.
Ben, you have the microphone.
Thanks. I'm not sure that I understand the purpose of signaling the choice of whether to use a self-signed certificate or a CA-issued certificate on the wire. I would have thought that that's simply a local configuration matter. Can you explain why that's in there?
Because it's an assertion about the security being provided. And since we do not have an orchestration system, see this slide. It's hard to flip slides, by the way, here. But I want to know. I want to know that you are you. You are identified. And you just give me a self-signed cert. Do I trust it? If we've agreed that we're running self-signed, that's fine. But if I think there's a CA, you could do a replay of somebody else's cert from that CA, et cetera. We're trying to deal with that. But I see where you're going, Ben, and I think that is worth some more discussion.
Yeah, I understand all the points you make. I'm just not sure that needs to be on the wire at that point in the exchange. I think that, if I am configured to require a CA issued certificate and you send me a self-signed one, then I drop it on the floor and walk away. I don't see how that flag helps. But I think the rest of it's perfectly valid.
We can discuss offline. I hear you. But I think we should have Rob and Russ in on that part of the discussion.
Okay, the microphone is.
Rob has typed into you in chat, by the way.
Yes. So microphone and queue is cut with me. Minto, you have the microphone.
Thanks. So does the TLS CA-based certificate need a IP address-based configuration to identify the identity?
I did not understand the question.
So the certificate identity verification, right? That is required. That is need to be identified, right? So does it need a local IP address-based configuration, or it rely on the management network all the time?
The certificate is presumably provisioned into the server side device by an out-of-band enrollment system. Okay, for instance, when you bench the device before you rack it, you blow in its management interface address, et cetera, and you blow in its server certificate. Is that making sense?
Sorry to jump. The client to identify the certificate, right? Does it verify with a external server, or it has to be configured internally, or the certificate is a group certificate?
If it is CA based, it is external. There's a provisioning system. Probably, if you're interested in how one might do this in detail, go look at RPKI router keys. And the router, when it's booted, it could create its own keying and ask the CA to sign that certificate and then push that signed certificate back to the router. Or the CA could have created the certificate and pushed it to the router. Either way. But now we're down into how does one provision certificates? And that's pretty standard stuff.
Yeah, Minto, unfortunately, we have to move forward. Randy, I think to Minto's point, what is being requested is more details about the contents of the certificate, since some TLS certificates are bound to IP addresses. So you want to go into more detail about the profile you're expecting. Bill, you have the microphone?
Hi, Bill Fenner, Arista Networks. On the topic of how the configuration gets to BGP, I think the question of how is definitely a matter that's local to the router, but when, I think, is more of a question for the protocol definition. And I suspect it's more of what Randy meant by this slide with questions is once you've learned enough information, how do you decide when you've learned enough information to push it over to BGP to get it to start the session? How do you decide whether to reset an existing session with new
Bingo.
information.
Yep.
Thank you, Bill. So I'm the last one to supply comments. Randy, I have a few comments for you. I will not repeat the majority of my comments from the list. Hopefully we'll follow up for those there. One comment that was useful to make is you've pointed out, you don't like stochastic protocols. For this mechanism to take effect, you're relying on a bootstrapping mechanism that has much the same properties. For L3ND to be able to start its TCP, it has to hear the hello. For all of the shout in the dark protocols, they take action similarly because you've heard that. Second comment is your attributes. I wanted to ask why you chose to do those, because the requirements portion of our work on this, you had fought very hard to actually remove anything that resembled such things, termed as role in some cases.
No, to be specified a fixed set. Here it's open, operator choice, whatever attributes they want.
Okay, I think we're slicing at details. Third comment that I had was about the lowest address for bringing up the session for determinism. I understand why you did that in the sense of LTP as an example uses something very similar. I would suggest that you take a look at how this impacts using this mechanism on a network segment that's broadcast, or that can be used for like a route server. I believe this tie breaking will encourage full mesh connection rather than hub and spoke. And my last comment for your presentation is for your encapsulations. You make a very strong point about not wanting to have conflicting multiple sources of truth. BGP just simply needs to know what the addresses are on each side. Why exactly are you advertising redundant subnet information?
Where is it redundant?
If you've established a TCP session with your L3ND TCP port, you had enough information to set up your BGP if it's the same encapsulation. If it's a different encapsulation, ULPC provides the IPv6 address. You have that provisioned locally. You don't need to be told about it from the remote side.
The remotes, I'm in the encapsulations, the other side could have given me multiple IPv4 addresses, for example. Which one does it want me to use?
That's part of your ULPC for BGP.
No, right? It's in ULPC. The other side could have said, here are two IPv4 addresses on my side, a primary and a secondary. And then at ULPC, the other side can say, hey, here's the one I want you to use. And it could have been the secondary, or it could have been a loopback.
Right. Your BGP state is the address you want to use. Why do you need to know the subnet?
Oh, pardon me. You're just saying prefix length.
No,
Good
this is
point.
not about the prefix length inside ULPC. If you receive a ULPC message, as you see on the screen, with your IPv4 peering address, that's sufficient information for you as the receiver of this to look at your routing table and to choose what outgoing interface to use to reach this. If it's a different encapsulation, let's say it's discovered over v4, and you have a v6 ULPC, if you don't have a local v6 address, you don't care what the remote side's address is going to be. You're going to make your choice locally. These considerations are exactly the same as IP address selection for v6.
Can we continue offline, because let's not waste people's time with my not understanding.
Okay, in that case, we're done with your presentation, and we're moving to the discussion about how we move forward. I'm going to go back to the chair slides. We had scheduled some amount of time, beyond this, but I think we only need a moment. So, for BGP auto configuration, this was our intent on how to move forward. The original plan that we had, was to start the questions after we had the January interim. We've had our presentation now. So where does this move us? Originally, when we had only 3 proposals on the table, the questions that were going to be going to the IDR list about auto configuration for adopting a solution was question number 1. What layer did we want to actually have our solution work at? And the option could be, layer 2, layer 3, or potentially a solution for each. Once the question's been answered about which layer we wanted, what proposal we'd like to take for it. The L3ND discussions have motivated us to ask additional questions as part of the adoption call that we'll be issuing. And that's specifically, what security solution are we desiring for our protocol? Is certificates an important thing, or is a shared secret sufficient? Mostly motivated by whether or not we're using security, and to some extent extensibility. Do we require reliable transport or not? And it's important to note that, as an example, L3DL does have its own transport mechanism, which is not TCP. So I'm going to pause here briefly to see if there's any questions about how we move forward on the adoption calls, and we'll be taking this up after IETF. Okay, if there are no further questions, this ends our portion covering BGP auto configuration. Actually, I see that AC has entered the queue.
Yeah, so you're going to, this is AC from Cisco Systems. You're going to ask all these questions like generically or for each, and I mean, these questions, and then take the results of that and apply it to the, I guess there's 5 odd mechanisms for BGP auto discovery? Or are we going to,
It's 4.
I don't understand the move forward exactly. I mean,
so did you care to respond to that?
I'll let you go ahead and respond to that. I had a question for the LSVR folks. So I'll,
Okay.
if you want to respond to it, otherwise I will. But
yeah, my brief response, AC, is that this is the set of properties we want to pull for, and this covers the full spectrum. There's currently 4 candidates that are requesting adoption, which is the LODP1, L3DL, Draft Minto, and L3ND. So.
so AC, I'll ask this in the question. We noted that these are the questions the adoption would have, but normally, as you know, notice when I send out adoption calls, I send out a set of questions specific to the particular draft. But in these 4 drafts, some of the questions are inherently the same. So what's going to make more sense? Sending out the questions and then the adoption call, or adding these as questions on every adoption call? In the end, the chairs are going to read all of the adoption calls and figure out what to do. So it doesn't matter to us as chairs. Do you have any preference as a working group member? I'm not seeing AC jump back in the queue. So folks, do you have any preference? on how we do these calls and ask this question, because maybe you're saying we should adopt all four. We like the two of the layer 2 because they have two different properties. We like two of the layer 3 because they have properties. If not, we'll take our dart and discuss it as chairs and send out adoption calls. Any preference?
If you have further inputs, please let's take those to the list. Otherwise, we'll be sending out the adoption questions sometime after this IETF. Our next item on the presentations is an update on the BGP Yang model. Mahesh. Gary, did you want to share in room or should I share?
Do you want to share? Perfect. Thank you.
All right. This is Mahesh Jetanandani, and I will be giving an update on the BGP Yang model. We are at version 13. Next slide, please. Okay. So we have been evaluating the structure of the model, and we believe at this time that it's holding up with respect to any further or future extensions that we believe are going to come for all the changes that are coming to BGP. So there is a update as far as the L3 VPN model that I'll cover in a later slide. So what are the other changes? So the model has been updated to match with the change we had to make for BFT Yang. BFT Yang had to be revved with an RFC 9127-BIS, and those changes have been incorporated into the model. Support for BGP Med considerations has been added. Send community, which was previously an enum, is now an identity, and therefore will allow for extensibility as we add other types of communities, including white communities. And the last major update in the model was the addition of large communities. Next slide, please. So that was the base model. Now, as far as the policy model itself is concerned, we have added support for the next hop, both for match and a set. So same thing for large community set. And then we have gone ahead and also added an example for what that configuration might look like using this particular BGP policy model. Next slide, please. Okay, so what are some of the outstanding issues? By the way, we have a running list of all the issues at this particular GitHub link if you ever want to go there. And you're free to add to those list of issues if you feel it's not being covered adequately here on the list. Some of the major issues, and this by no means is an exhaustive list. There is some discussion around the maintenance of extended communities as an IANA module. So that's going on. Extended community type defs. It somewhat overlaps with the definition in RFC 8294. And the generic community types have the formats as described. But our apps, what is missing is the type subtype. So that's one other issue. The no SPath regex issue, we tended to believe that at this time it's vendor specific, and we are inclined to leave it as a string because it's hard to come up with a regex for it. Finally, replace PRES in the SPath. So again, the semantics are different between vendors. Hard to program it or put it in the model. Next slide, please. So what are the next steps? We believe at this time, at least the structural issues have been addressed in the model. The other part is how it interfaces with the other pertinent Yang modules, in particular BFT, TCP, and the keychain module. We have gone through and examined how we interface with them, converted a reference to keychain as a reference only. So that's all we need to do in the BGP is provide a reference to the keychain that is going to be used. The BFT interface cleanup that we talked about with respect to RFC 9127 BIS. And then the open issue is with the TCP/AO configuration, and it's still something that needs to be resolved, but it needs to be resolved between the TCP model and the keychain model, not something the BGP model is directly impacted. As I said, the only thing it needs to provide is the keychain reference. And then the final item, the L3 VPN Yang model. So we did look at the L3 VPN model. We have suggested some changes that would be needed in that model to, if it's going to augment the BGP model. And then also we have an example that works with the provided changes in the model. So that's again an example of how somebody could use the BGP model for and augment it for their purposes, like L3 VPN. Right. So the only other thing that I would say is we have the set of issues that I have identified here and the exhaustive list to go through, at which point I believe we should be ready for getting the draft through last call. Questions?
Jeff is in the queue.
Jeff?
I should not be in the queue. Ben, you have the microphone.
Hi there. On the question of the AS path regexes, I'm currently working on a tool to evaluate the regex syntax that appears in RPSL. And as part of doing that, I've got an AST, a parser and an AST, and I'm in the process of turning that into an evaluation implementation to kind of render it down to the vendor-specific flavors.
Okay.
I suspect there's probably a fair amount of overlap in terms of what I'm doing and what you would need to do to make that something better than just a vendor-specific blob.
Yes.
So I'm happy to work on that with you if you'd like.
Sure. Well,
Okay.
definitely. You can bring it in the form of a git push up request or. Yes. Okay.
Sue, you have the microphone.
Sue, did you have a question?
No, I don't. I have a problem with Meet Echo I'm trying to fix. Thank you.
Okay.
Thank you.
Okay, thanks. Thank you, Mahesh. Okay, so with the Yang update being done, our next portion of track is moving into the BGP routes with color discussion. We have a brief item to present from the slides for the chairs, and then after that, we'll be moving into the presentation for BGP CAR. So, as was mentioned earlier, we had a very energetic interim on January 24th that generated a lot of discussion back and forth, and the discussion was, as we were hoping from an interim, far more interesting than the presentations were in some respects. And part of the back and forth led to the observation that we're not necessarily talking about the same things in some respects between CAR and CT. I did a write-up that is linked in the top of the slides here on the IDR mailing list. You are encouraged to go read that and please respond, especially the authors, to make sure that the assessment is fair to your proposal. The motivations for the questions was to understand what those points of dispute were and try to clarify what they actually mean. And the two questions that got percolated to the mailing list effectively were, number one, how does route resolution work for your feature? And number two, how does route origination and propagation work? And It's our assessment in the response that you see at the top that for each of these proposals, the functionality in terms of what can be accomplished by the protocol format and how it's actually carried through BGP are comparable. They're doing roughly the same things. The thing that is absolutely also clear from the discussions is that they certainly, in terms of NLRI format and how the information is carried, are not identical. And even though they have similar functional overlap, it's clear that each proposal is trying to bring a specific operational model to how things work. So that will, I think, be part of our longer discussion about adoption. And one of the things that I encourage the presenters for the next set of slots to discuss is the operational considerations for what your mechanism looks like and what does your format specifically bring the operators. Aside from these details, the largest remaining functional comparison point that we have between CAR and CT is CAR does add a idea to BGP of carrying optional components as part of LRI to try to decouple the formatting that we have from BGPLU, where we carry a label stack that is non-key but isn't explicitly called out as part of the structure of the format. So that will be, I think, one of the more interesting discussion points as we move forward. It's important to note that both the CAR and CT authors have requested working group adoption. So we'll be figuring out as part of this presentation set and working group mailing list discussion, how do we want to actually proceed with the adoption questions? That has not been settled at this point. Sue did, as part of her analysis, effectively add on 2 additional questions. Question 3 sort of hits the things that were motivated by our discussion in terms of route diversity and local convergence properties. So, a point that the CAR authors have brought up repeatedly is, they believe that there's local convergence issues. The question Sue has is there really a local convergence issue with CT when the same RD is used? Kayer has raised himself that the CT document is not necessarily clear in some respects about when you would want to use distinct RDs versus ones that are shared in many places, and the text there could actually be cleaned up a little bit. And a question towards both these proposals is how integral to convergence is AIGP? So that would be a useful thing to discuss as part of the main list, and we'll kick off a specific thread there. And in terms of fallback, can the different proposals actually handle specific sets of fallback? The CAR document calls out explicitly what the fallback order should be. CT does not, and it may be worth the CT authors adding that as part of their discussion points. So at this point, we will be moving into the CAR presentation. Then Jaya, you have the microphone. So we see that Dan Jaya is attempting to share microphone and is not sticking for some reason. Incidentally, this is why we ask people to test their microphones at the start of the session. I'll give him one moment to try again or to respond in text as to what's going on. The 2 options for moving forward, if there continue to be microphone issues, is alternate presenter. You see that Swadesh is on the call as well. Or we can try again after CT has given their presentation.
Jeff, have you handed DJ the slides control?
I have not.
Hello.
The micro. We can hear you now.
Okay, great. I had to use a different browser. Got your comment. I thought I had checked it, but looks like it didn't work. Didn't stick.
Okay, you have the presentation.
Sure. Thanks, Jeff. Hi, everybody. I'm Dhananjay Rao from Cisco, and I'll be covering BGP color aware routing once more. Next slide, please. So BGP color aware routing extends BGP to establish intent aware paths to a destination. We've indicated before, intent is signaled using the color construct because it's already established, defined as part of the SR policy architecture. What this means is on a BGP service route that, for example, an L3 VPN route that requests a particular intent, it's indicated by using a BGP color extended community. Next slide, please. What BGP color aware routing does now is it actually sets up the transport path for a given endpoint, but for a given color. This allows multiple routes to be used in the network for different intents for the same destination, as you see here, the endpoint for the endpoint E3. When at an ingress point, the service route needs to be then steered, or the traffic for it needs to be steered over a particular intent aware path. The steering or the resolution uses not just the BGP next hop, but also the color that came in the color extended community, and then resolves over a BGP color aware route for that color. This works for any service. Next slide, please. The draft, of course, goes into a bunch of details about different aspects. We have covered some of them before. We'll cover a few, again, in this call. Next slide, please. So we are introducing a new SAFI in BGP because we needed to signal multiple instances for the same prefix. It's an operational requirement. You don't want to burn different IP addresses, so you have the same IP address, but you want to issue different routes. We use color. Now this is defined as a evolution of BGPLU SAFI, which is being used in the transport networks today. But at the same time, we are modernizing this, the use of the SAFI by in BGP CAR, addressing some of the limitations that exist with BGPLU. At the same time, we are maintaining the functional and operational consistency of BGPLU in terms of the route processing, the best path, other things as we'll see along the next slide. An illustration below kind of gives a sense of how a car route looks with respect to a BGPLU route. We find no reason to use any complex VPN constructs or machinery at every transport hop to achieve this purpose. Next slide, please. This is the proposal for the car LRI. It's a simple extension to an existing BGP route. In addition to the prefix, you have the color. The color serves to act as a distinguisher for the route, but it also provides the intent provided by the route. This is optimized for the majority of deployments where you have network devices that operate within a color domain. That is, they have the same consistent color mapping. We do support the the exception cases. We'll cover it later. Next slide, please. We've gone through this before. I mean, we've defined it to be the simplest data model we can use. And it enables the most efficient route processing and storage. We are talking about an all much increased scale than what you've seen with BGPLU today, because now it gets multiplied by the number of intents that may be supported. So we need to focus on efficiency. That's what we've done. This model, as it works very similar to BGPLU, it inherently provides ECMP awareness or backup paths at every BGP hop. You'll see details in the next slide. This provides faster localized convergence. We again, we don't have to deal with complex workarounds to make things work because we use an import mechanism. We don't need that. Next slide, please. So this is the illustration for that case. As Jeff said, we've described it before. It's been debated. You have two ABRs here, 231 and 232, originating a route for an endpoint E3. Now that naturally, ends up being, treated as multipath at the ingress nodes of the domain. Get a common label, next hop self. What gets propagated is just, the route from those border nodes. Any failure of the ABR gets handled locally within the domain. There's no churn, outside. With CT, you don't get this by default. The user unique RD, those RDs end up creating unique routes. The routes, the LSP propagates all the way to the ingress PEs, and any kind of convergence has to happen at those ingress PEs. And at the same time, you have all this, failure propagation, the churn going across, outside the domain. Some workaround has been proposed, and as we discussed it previously, that fails to address it because it still propagates the churn outside. To Jeff's point, I mean, just to address it there, or I guess his question, if same RD was used, I mean, you could potentially use same RD. That's another way, because this in RD you have that option, but it still doesn't take away the import processing that's there, and it seems redundant, at that point. Same RD, I don't know how we end up doing automatically, because there isn't enough space to put an ID that says that multiple devices come up with the same value. I don't think there's enough bits to put the 32-bit color in there. And then, if at all that's the solution, then it kind of renders the RD meaningless. I think. Next slide, please. Now, the other critical aspect is really have we defined, a transport SAFI that is future-proof, right? I mean, because we are trying to move people from Bgplu to a new SAFI. We have taken that into account when we defined Bgp card. We put in extensibility, again, leveraging a lot of, experience from other Bgp SAFIs. So we have a route type, we have a key length, we have encoded non-key TLVs. As Jeff said, there is non-key data even today in Bgplu, L3VP and other SAFIs. We have provided a structure, made it, TLVs. We enabled, and that enables us to, add additional TLVs as needed, and that provides some benefits, as we'll see in the next slide. At the same time, we ensured, we maintain the packing efficiency. Again, we'll see an example of that in the next slide. So we think these extensions actually make this new SAFI as a good base for future extensions, future use cases, which we don't even are aware of today. One thing to point out is, even though we introduced TLVs, they are for the non-key data, as pointed out here. So from if you look at the NLRI, the prefix, the key, that's just like any other existing SAFI. Next slide, please. Coming to the encapsulations, so clearly this is a critical improvement with Bgp car. You can signal, of course, the same forwarding information, labels, SIDs, etc. But now you can signal them without having to overload the label fields of the existing SAFIs that have that can only signal labels. You can signal multiple encapsulations, and we can signal different values for those encapsulations. So you're not constrained to ensuring it's the same value that's used. That may not be appropriate for different encapsulations. As I said earlier, we maintain packing. For example, the label index is a good example. It doesn't need to be carried in an attribute, which completely breaks packing. This, of course, makes things efficient in the steady state, but it also provides a benefit when you look at migration. When you have these different encapsulations in the network and you're moving from one to the other, today what you would be forced to do is set up different control plane distribution channels, and generate duplicate routes for the same information with for different encap, and make sure they travel in a disjoint manner, such that the ingress nodes that need it receive it. That's a lot of operational complexity. We've taken care of that here, because now first of all, you don't have duplicate routes. You use the same set of control plane sessions. It's more efficient. The protocol automatically handles this scenario that really provides through OpEx operational simplicity and OpEx reduction. Next slide, please.
Interrupt for a moment. Sue, do you have a clarification question? If not, we have a time slot for discussing things at the end of this presentation sets. Sue, we do not hear you.
So, and afterwards.
Repeat yourself, please. Okay, you've taken yourself out of the queue. Let's continue.
Okay, thanks, Jeff. So one observation, this was discussed before. One thing that did come up at the come out of the interim discussion is yes, there's an acknowledgement that there are these limitations with the the RFC 8277 encoding, and we would like to address it. This is a general I think expression, and including from the BGP CT co-authors. So BGP CT unfortunately does inherits the same limitations. Whereas with BGP Color View, recognize those limitations and address them from day one into the design. Next slide, please. Okay, next top resolution, nothing really new. We've covered this before, so we could probably skip it in the interest of time. In general, it works across both traditional transport technologies as well as the newer, color aware mechanisms. Maybe one thing to bring up here is there's been some discussion about longest prefix match, and maybe it's a good place to mention that of course CARD supports the longest prefix match when it comes to next hop resolution. So if you hear anything to the contrary, that would be incorrect. Next slide, please. Again, another key goal from the beginning, and this again talks to the operational, simplicity and the experience. BGP CAR is, completely, compatible with the SR policy architecture in terms of using the color, steering mechanisms, fallback, etc. And that is a model which, has multiple implementations and is deployed. So you get that, sort of leverage. Next slide, please. As I said earlier, there can be exceptions where networks come together and they have different color to intent mappings. This is nobody starts with this day one, but it can happen. So we have accommodated that by leveraging an extended community called the local color mapping extended community to signal the local color within a domain when routes come from other color domains. The NLRI, however, is immutable, does not have to be rewritten. It is preserved end to end. And then even if the color, in the NLRI is, now, from a different domain, the prefix is, unique in the interdomain transport network. For example, it's a PE address, so that makes the e-commerce tuple, unique. Next slide, please. This is essentially a reiteration of some, it's like more a set of clarifications because some points have been raised in the past which we've addressed, but sometimes they come back. I don't think at this point we need to go through it point by point, but they're there for reference if it's helpful. Next slide, please. Again, there are other aspects, described in the draft, and for example, different scaling designs. Again, some of these are actually used today, so there's nothing new. But we've done an analysis of the trade-offs and some optimizations that can help. Again, there's CAR also, even though the focus is largely on transport here, but it's routing, so it can extend to the VPN domain, like between a P and C. So we would define an extension there. Next slide, please. Again, now to summarize, CAR is designed as an evolution of BGPLU, but with intent awareness. But we also taken care to design it to be extensible, to accommodate new use cases, support multiple encapsulations with efficiency. We think it's a really good base framework that can be extended with lower head for different use cases. There's a heavy focus on better protocol performance and scaling, both in terms of processing and memory storage. This is important. Again, finally to restate it, yeah, it works across both traditional networks as well as newer technologies. Next slide, please. Yeah, I think we can skip past this. It's just an output, for reference. So I think bottom line, the base functionality is stable. We believe we have two, known implementations that interact with each other. We believe the draft is ready for working group adoption, and would like to reiterate the request. Thank you.
Thanks, Sanjay. 3 points, and then I'll yield to Sue. Ask Sue to stick with clarification questions. We have discussions scheduled after the presentations are done. Point number 1 here that I wish to raise, you have 2 implementations with interoperability as raised on the mailing list. That means you're squatting on code points. Please address that ASAP. We should not be leaking that out into the internet at large.
Sounds good.
Point number 2, based on how the discussion has evolved across the mailing list, I wish to caution all of the participants about making value judgments about other people's implementations. Giving a specific example, you're raising, what you think tables look like in terms of import-export behaviors for CT. You've similarly responded to Kaliraj, making assumptions about longest prefix match behaviors in your implementation. Let's focus on what the functional details look like, and if we find the need to clarify, you're welcome to do so, but it should not be a requirement here.
Sounds good.
Okay, and Sue.
Thank you, DJ, for your presentation. Let me go back and ask you a clarification question. It had to do with when you were trying to answer Jeff's question, and I got a little confused. So it was the question about the unique RD and how that would work. That was actually my question. I had meant perhaps you could explain how it doesn't work or how it doesn't do local convergence. I do note that the CT document needed to specify that it could be run in multiple RDs or one RD. When I pinged them, they responded to that. So would you go back to that point in your slide where you were discussing that? Bring up the slide and just sort of go through it. I thought it was a side point, so I didn't want to interrupt your flow.
Sure. So the of course, and just to point out, what's illustrated here is a BGP car, and Larai. So we would still be now talking about CT. The difference, the main difference, I was describing is by default CT would originate routes with unique RDs. So the same route for E3 C1 as originated by 231 and 232 nodes would go with different RDs, and hence they would not by default get merged in at the nodes, ingress nodes 211 and 212.
That is
Right?
agreed. I was looking for the case if they had a single RD for the comparison that I thought you made, and I just
Sure.
it may be the line I didn't hear clearly what your comment there was.
Sure. I think I was just pointing out that yes, with same RDs, some of the issues could be ameliorated, but it still has issues. I guess one comment, I don't know if I should restate it given Jeff's comment, but it still requires an import process, a procedure at at the nodes 211 and 212 to get that merge happening. Um, the actual comment I was making was it is not automatic, right? Because now you have two nodes that have to generate the same value to get the same RD, and there, given how what the types of RD we have, there aren't enough bits when in the RD to fit in a 32-bit color value, assuming color was a way to generate that same RD value. Perhaps there are others, but that was the comment I was making.
Okay, so your comment.
We're cutting into other people's presentations, and if we could save this at the end.
Okay, I will. I didn't mean
So
to
I want to add
go
one more
beyond.
point here is,
Go ahead.
yeah, with the same RD, imagine if it's originated from the E3, because that's what Kaliraj just mentioned. If it originates from E3, we are carrying the same value. That means the prefix E3 as well as RD is also carrying E3. It's a repetition of information. I'm not sure for what reason, but we are carrying the same information twice in the NLRI. So I don't know what's the point of this data model if we say we will propose same RD.
So this is a great point for the authors
For
for
the
CT to look at.
discussion.
So
Yep, we'll leave
let,
this to the discussion. You've clarified your comment. I will ask more in the discussion point. DJ, thank you for going through that. Um,
Sure.
we'll pick up the rest of it during the discussion. Thank you.
Thank you.
okay. So we're going to move to the CT presentation. We also do have an LCU presentation afterwards. The goal is to leave as much time for discussion about the sets of things. And I do want to point out there's interesting stuff in chat. Please take that to microphone once we're done with the presentations. Kaliraj, you have the microphone.
Hi everyone. So I'll be presenting BGP City again, and we will be repeating a lot of stuff, but I want to focus on a few slides so that we save time for everyone. Next slide, please. So this is the quick agenda. It's a recap of the problem statement, and I want to touch base slightly on why we need a new address family, and then what are the problems with including color in the LPM lookup key. Though this is an implementation detail, but it drives how the protocol should be designed. That is why we are talking about this. And then there are some repetition of explanation of what are the constructs in BGP-CT and how do you express your intent in BGP-CT using mapping community. So in the chair's summary slides, Jeff presented the analysis that both the solutions are almost equal. But I feel that how you express intent in BGP-CT is much more signaled than what you can do in CAR. We see that is underspecified in CAR. So I just want to point that out. And then we will just go with the current status and executive summary. Next slide, please. So problem statement is it's just doing intent-driven service mapping. So basically, irrespective of intra-domain or inter-domain, you have the same way of how you specify, classify transport classes, transport tunnels into transport classes, and how you do service routes resolving over a set of transport tunnels in a desired fallback, and where each route can have a different fallback, and how it works with how to extend BGP to carry the signaling information across an AS domain. Next slide, please. Yeah, this is just a reference diagram. It just shows a BGP-LU network trick, and it shows the different redundant ASBRs, redundant ABRs, and the PEs, each PE having multiple color tunnels, and how the colors are not visible today when you're using BGP-LU to the other domains. So, for example, PE25 cannot put a traffic on the gold tunnel to PE11. Yeah, next slide, please. So why do we need a new address family? So this is the first thing that we explored. So why not reuse or hack existing address families like LU, SRT, L3VPN? So with extending LU approach, the main problem is that even if we do some changes, agree on having it negotiated on a per session scope capability, we cannot guarantee end-to-end SLA, because on the path, if there is an old LU node which does not support the new mechanisms, it will just re-advertise the route, the intent-based route, without following the intent. So the ingress PE cannot be sure that the end SLA has been guaranteed end-to-end. So this is the main reason why we didn't go with LU, because when we are going for new extensions, it's good to just have a way which works always. And if you have a route, for example, if you have a city route or a transport class gold and the ingress PE, we know that end to end the gold tunnels are up. So we want that kind of a guarantee. That's why we didn't go with LU. And using AdPath ID as a per session scope, AdPath ID is per session scope. It doesn't work really well as an originator of the route. So RD is a better end-to-end distribution. That's the reason for using RD other than just relying on AdPath. And that goes with LU or any other approaches like CAR, which are using AdPath. And overloading L3 VPN, of course, I think everybody agrees that we don't want to put more transport routes into L3 VPN, so we did not do that. And carrying color in the NLRI, basically color is an adjective, it's not a noun. So it's, instead of carrying it an NLRI, carrying it as an attribute makes more sense. And more on this on the next slide. It also ties in into how the internal resolution data structures are built. And use of RT, target, it allows for RTC-like mechanisms, providing on-demand next hop. So if you use LU or those kind of things, then you don't get this. Get this also. This helps with scaling. This helps with the PubSub model, and thus we have a new API 76. Next slide, please. Yeah. So in this slide, we have tried to summarize between the different proposals which use color in the key, either as IP colon color or color colon IP. And another model that is CT users, where you have different transport rates of different colors, and each one have just IP prefix. So we have seen the different functionalities that may be required. Where, for example, you do a longest prefix match on endpoint color 1 and do a best effort fallback on the best effort tunnels. So this is possible using CAR because it uses IP prefix colon color, and color is at the end of the thing. So, and if you're using a /64 kind of lookup key, then it will support the best effort. But it's not possible using SRT, which uses color colon IP prefix. And if you want to fall back from C1 to C2, that is also not possible with CAR. With the pure longest prefix match, there may be other arrangements possible which are less efficient, and it's not possible with IPSRT also, color colon IP also. And LPM lookup on non-host prefix length route. So this is, I think, it's one of the main things. I mean, in the responses, Car others said that this is academic, but I don't understand that point because I hear that SR basis locator route is one such route. So if you have a prefix non-host prefix length, basically think about how you organize your data structure. I mean, you may have 1111/32 with color 2, and then 1110/24 with color C1. And if you want to match 1111 next hop with color C1, then it will do the longest prefix match and hit the more specific thing. So we need to do some jugglery here. And it is, of course, supported in color colon IP prefix and city. And carrying best effort tunnels, it's possible with IP colon color because color is at the end, but it's not possible with SRT. That's a color colon IP prefix. So we see that it's kind of evolution, and because CT does not include the color in the NLRI at all these things are possible with CT. Next slide, please. So this is just restating the solution constructs. And the main things here I want to point out is the transport class. That is the construct that equalizes the different transport protocols. Some of them inherently know the colors, some of them may not. And then we have the resolution scheme and the mapping community. So these are the important things. The mapping community is not, it's basically, we define it as any BGP community. So it is not like a one-to-one mapping with a color. So most default cases, it will be a color that you auto derive the mapping community, but you can have a mapping community that can describe the actual fallback. We will have an example of this. And I think this is the missing piece. This is the difference I see, that it is not there in CAR. I mean, I don't know how you do. I have asked those questions on the email alias, and I'm expecting a response from CAR others. So if R1 wants to use color C1 as a primary and C2 as backup, whereas a different route R2 wants to use the reverse, C2 as primary and C1 as backup, how do you express this? If it needs config changes on the box, then basically you don't actually signal it. So, but with CT, we can signal it. Next slide, please. Yeah, so this is just the same LU network. It is converted to CT, and you see all the color tunnels extended up to the P ingress P. Next slide, please. Yeah, so this is just an example of how you express intent in BGP It just gives a concrete example of how you do the mapping and how you can signal using the mapping community what fallback scheme the route wants. And we don't see these kind of details in the car document. It'll be good to add how exactly it is done. Okay, next slide, please. Yeah, so these are the advantages, and this is like a repetition from previous sessions. I think instead of going through this, I'd like to respond to some of the comments that were made in Carl's presentation. One was about the limitation of 8277 encoding. So our point was to move non-key fields out of the NLRI, not to add more of them to the NLRI. Well, if you have to add more to the MLRA than what CAR is doing by segregating them out of the key and non-key, that's all. That's one way to work around it. But it will be better if you have forwarding information scoped on a per next hop basis, and that next hop be carried in an attribute. So what our suggestion was to go with that model where we take forwarding information or non-key information out of the MLRA. I just want to clarify that. And yeah, and the point on local convergence. So, like Sue was pointing out, I mean, if you use RD at the egress, I mean, if you use a city route origination at the egress PE, then, like Jeff points out, these two proposals are identical. You have the same kind of prefix. You don't have any different RD that the ingress PE sees or the ASPR sees. And to the point where why do you need the IP in both the RD and the prefix? I mean, you should look at RD as only the identifier. It's just an identifier, and you have flexibility to what do you say? Configure the RD like you want. And like Jeff has been pointing out, it's okay if we bring up a new RD which encodes color, or if we have some way to have a wider RD. I don't know if that's possible, but we can have RD that a model of RD that can encode color, and that's also will be equivalent. But in my opinion, it's better if the RD identifies the PE loopback because that gives a really good troubleshooting guide of okay, looking at the RD, I can know whether it is originated by PE11 or PE12, and when you have multiple colors originating from the P, then you will have different RDs, and that is why you need RD there in the first place. So you can use PE11 colon color 1, PE11 colon color 2 as the RD, and that gives you an easy way of identifying. It basically encodes both the IP address and the color. Though color will be 2 bytes, but for most practical use cases, that will be good. And I just want to bring up the point that whatever CT does, it basically protects the investment of operators have made in operational training, tooling, procedures. So it's like nothing new here. It's like using well-oiled machinery of L3 VPN in a new transport layer. Okay, next slide, please. Yeah, so the current status is that we are having energetic discussions comparing the various proposals, which is always good for the community. And we have requested working adoption, and we will continue to have those discussions and see how it goes. Thank you.
Thank you, Kaliraj. Again, request for clarification questions only. Sue's got the queue. Sue's dropped out of the queue.
From you. I don't need the queue. Thank you. Sorry, my bad.
Spanish?
Things that was just now mentioned. One of the questions was regarding the same RD originating from the originating P, as Kalira just mentioned. I'm not sure why we need to advertise again the repetition of the same question I already asked. That what's the point of sending P address is still a global. It's in a transport network. It's global. What's the point of sending the P address in RD? Because you yourself mentioned you're sending a PE1 colon some value, then a PE1 address. And again, you will do the same thing for another BGP CT route sent from the originating P. to achieve the convergence. So I'm not sure what is the point of putting a RD in front of, if you're saying for any local convergence, you need a same RD. I'm not sure where you're getting with it. That's the first point. Second point is for the multi, you are proposing, you you agree there are limitations for 8277 RFC, but you are proposing another multi next hop attribute to carry it. Remember, multi next hop attribute is also an attribute. We are talking about transport network where the label allocation is per prefix. For each transport CT route, you have to have a unique label. Now, if you start moving that to a next hop attribute, uh, it's carried in the attribute in the BGP update message. It's not put with the NLRI. So day one, you are making each NLRI unique. And remember, we cannot compare the BGP CTR card to BGPLU. BGPLU was just carrying a best effort today. It's a single IP address being carried for a particular PE. Now we may be carrying many intents for a PE address. So scale of BGP is going much higher. So I don't see a reason to break the packing right from start. There's no reason. We should try to optimize things when possible, and it will help when you are going across one BGP domain to another egress domain. That time it will,
So,
this
so,
packing will help.
Swadesh, I want to just ask a point. I really want to hear every word you're saying, and if you speak a little slower, the echo will cancel it out. Your words are incredibly important to me right now.
Okay, I will be a little slower. Yeah, my point was, uh, one of the things that has been agreed is that 8277 has a limitations because it encodes the label within the NLRI in the hard-coded fashion, which doesn't support multiple encaps if required during migration and coexistence, and as well as uh, it has the limitations for any future use cases like other type of encapsulation. So, and the proposal is that we should move to multi next hop attribute. Remember, it's an attribute in BGP update message, and we are talking about encapsulation informations like label or equivalent for other encapsulation in future. So if we start carrying such information in the attribute, not in the NLRI, as Carr has suggested, we are day one breaking the packing of BGP. And we're not talking about BGPLU anymore. That was only a single address for a particular global PE address. Now we are talking about multiple intents. That means multiple routes carrying the same PE address for each of the intents. And if we disregard the packing, I'm not sure where we are going with that. We should not do that at least. And that's what my point is.
Yeah, so my response to that is that even with BGPLU, doing per prefix label and doing the putting the label in the NLRI, you do have other attributes that are attached today to each at each BGPLU origination point, like uh, origin community or some other community which is used for operational use. So you're not getting that much packing today, even today. So complicating the protocol to do this kind of artificial packing. So that is what I think is unnecessary.
So,
So we can,
Khalid, it's a debatable. It's always put. I'm not sure it's always put when you go to EBG domain, all origination, at least originator ID is removed or those
yeah.
things are removed. So we can take I've clearly said when I send it to remote domain, we can always take the advantage of packing. This is a multi-domain transport we're talking about. It's not a single domain. We should not talk in that
So
way. We should talk about scalable solution.
I'm going to remind everybody we have one more presentation to get through before we actually have full discussion about the overall solution set. So please restrict your questions to clarification questions for the moment.
Sure. Okay.
Do you want me to take your first question right now, or?
No, we have one more presentation to do.
Okay. Yeah, we
So
can take a
Srihari,
second.
do you have any clarification questions? Srihari, we don't hear you.
Me, Jeff?
Can you hear me?
Hello? Can you hear me, Jeff?
I can hear you now.
Yeah, this is not a clarification question. I wanted to bring up the color mapping. If you think this is a good discussion for the open discussion, I can come back later.
Let's come back to the open discussion. We'd like to give everybody a fair shake. Ketan, do you have any clarification questions?
Yeah, Ketan Talavlikar here. Yes, I had a clarification question. I heard, Kaliraj, I heard you mention, talk about multi text hop attribute and how to carry encapsulations, multi encapsulation, but I
Mhm.
have not seen any of that in the draft. So is that something different, new? Yeah, can you
Yeah,
clarify?
that is a different draft, and it is not a prerequisite for CT, but that is basically just forward direction that I.
Okay. Okay, so just again clarification, then am I right to assume that CT is focused only on MPLS like BGPLU was currently, and then some more stuff would be added later for other encapsulations?
So CT has a section for other data types like SRv6, and for IP tunneling, that also it works. Those things are already supported even without multi-next hop attribute.
Okay, so I think we can take it to the list, but I just a quick thing, I think that's grossly insufficiently specified in my view. Thanks.
Okay, so Ron, you have a presentation?
Can you hear me?
We can hear you.
Okay, thank you. Perfect. Uh, Hello everybody, I'm Zan from ZTE. I'm going to introduce interdomain network selection via BGPLU. Next, please. Yes, this document aims to solve interdomain network selection problem using existing technologies. It attempts to establish multiple GPLU LSP of different colors for all multiple prefix to stitching multiple network segments. This document describes the colored BPLU LSP, which contains two options. One is to define the multiple paths for the same destination prefix and advertise the BGP update message. And each update message can contain the color extended communicated with different color value, which helps to select the land and lying resources. This mode require additional pass function defined in RC 7911. The other is that multiple prefix and multiple colors are configured on PE. One prefix corresponds to one color. This mode doesn't require two additional pass functions. Next, please. Yeah, this is the colored BGPLU capability advertisement. We use the capability advertisement procedures, which is defined FC 3392 to determine whether the speaker could use colored BGPLU instances with a particular peer. The fields in the capability optional parameter are set as follows. For the capability code field to be defined, which indicates colored BPLU instances capabilities. And for the capability value fields, it includes AFI and SAFI. For the AFI, value is 1 or 2. For SAFI, its value is 1 unicast or 4 BGPLU. Next, please. This is the deploy considerations. All routers require the colored BGP LU capability advertisement. If transit network domains that don't support colored BGP LU, process as follows. When the colored BGP LU label receives the BGP LU route, if it continues to advertise the BGP LU routes to the upstream labels that supports the colored BGPLU. The BGPLU routes shouldn't be changed to the colored BGPLU routes. With receiving the colored BGPLU advertisement from the label that supports colored BGPLU, if the advertisement continue to be advertised to the upstream label that doesn't support colored BGPLU, the advertisement should be changed to BGPLU advertisement. That is advertise one out of multiple paths. The reason for this definition is that we think the ingress node can determine that this colored which colored BGPLU is end to end. Next, please. Yeah, here are two topics initiated by Chair Jeff. The question one: how does root resolution work with your feature? For our colored BGPLU is recursive and color wired. We use color and next hop in the lookup key, and we will choose and lay SLA paths. They include SR policy, SGP flag, FA, and SVPTE, LPM based on policy. Next, please. For question two, root origination and propagation. We consider the following example of establish multiple BGPLU LCP for different colors in across domain scenarios. In this figure, P1 advertise two paths. 1.1.1.1 path ID 1 carries the color 1 attribute, and 1.1.1.1 path ID 2 carries the color 2 attribute to ASBR1. P1 advertises the bonding between prefix 1.1.1.1 and label 200. Because of the end node, both paths had the same label value 200. ASBR1 receives these two paths from PU1, and when sending to ASBR2, it modifies the next hop to itself, and allocate two new labels based on prefix, path ID, and color. As shown in the feature, ASBR1 sends two paths to ASBR2, 1.1.1 path ID 1 carries color 1 plus label 201, and 1.1.1 path ID 2 carries color 2 plus label 202. Similar, ASBR2 also generates two different labels based on the prefix, path ID, and color. As shown in the feature, multiple end-to-end BGPLU LCP are established. Different BGPLU LCP selected and lay SLA tunnels according to their colors. Next, please. Yeah, next up, comments are welcome. So we think this solution is very simple and easy to implement, and it don't need to do a lot of protocol extensions. So I think we think it's already to call for adoption. Comments. That's all. Thank you.
If there are any clarification questions for Ron before we open up for general discussion? Ketan.
Clarification question. Just a clarification question. I mean, isn't a label considered a non-key fee for the BGPLU? And I mean, how are the paths managed if there are different labels allow a signal with different paths? Maybe I missed something, and if you could clarify that part.
Sorry, sorry. Can you say it again?
So the isn't label kind of considered? It's not specified clearly, but isn't the label considered as a non-key in the BGPLU? in most implementations, let me
Yeah.
say. And if so, then how are different
Uh,
labels being signaled for different colors for the same prefix? Maybe I missed something basic. If you could clarify, please.
oh, okay. Um, we allocated the labels based on prefix, pass ID, and colors. So I think the color is the so I think the color allocated based on it. So I don't if it answer your question.
Take it to the list or on the chat just to save time. Thank you.
Oh, okay.
Justin,
Jeff.
here, you mentioned on the boundaries between speakers that do understand the capability and don't. You'll just choose one of the paths. I think you really need deterministic time breaking. You cannot have different BGP speakers advertising different paths.
Hey, Jeff, quick note. We've got 5 minutes warning.
Yes, unfortunately, thankfully, some of the cross discussion did happen earlier. So we are now open for resuming general discussion. Please queue yourself up.
Okay, thank you.
Thank you, Ed. Srihari. We are not hearing you,
Hello, can you hear
Srihari.
me?
We can hear
Yes.
you now.
Yeah. I want to open up the conversation that you've mentioned in the recent today's chat as well as in the last interim. This discussion did come up about the color mapping between the domains. This is something that I want to make sure that we all have a common understanding. Specifically with respect to the car, they talk about bringing in the LCM, which brings in the community mapping between the domains that have different colors. Now, clearly, this brings in complexity in terms of troubleshooting, because when we receive a prefix at a particular remote domain, which has the color embedded in the color NLRI encoding, which is the color encoded in the NLRI, and it has the LCM, which has a different color. So which color to really look into and which color to map to. So that's something that we'll have to go through on a node by node basis to the originating node to understand where the color and what's the real intent of this color is. Now, we've been hearing from Swadesh and DJ that this is a remote case and this is not a common case, but this is exactly what we did not hear a couple of years ago in one of the IDR meetings about specifically the color mapping between providers. So I want to know what is the real scenario here. I want to open up the forum to see what others have to say. I know we've heard from both the CT authors and the COT authors, but anybody else would want to comment on how easy it is to color mapping between providers and domains, and is it a normal case or is it a remote case? Would appreciate any comment on that.
Did one of the car or CT authors wanted to comment on that? Kalaraj?
So Srihari,
Yeah, go ahead, Swadesh. Sorry.
so Srihari, as we have already stated multiple times and replied on the list as well as to the Jeff very clearly, and Jeff has also summarized in his mail, it's clearly said that in the single color domain, it's a color in the NLRI that is the color. I don't think there's any confusion. And once it crosses the boundary, yeah, you can rewrite you can introduce a LCM which will carry the color. It's very clear. I'm not sure where the confusion is. Not sure why you're trying to bring up a confusion. It's very, for single color domain, it's very clear. It's easy. There's no LCM present. Your NLRI carries the intent color.
Swadesh,
And
the
if LCM
question
is
is,
present, that's the one. There's no confusion here at all.
Yes, so Swadesh, if I comment, I'm very clear on this. Yes, for a single color domain, yes, I am completely with you.
And
I'm
remember the
talking about
optimization we have
colors
done. And
between domains.
Surely remember the optimization we have done. We had make it work like BGP LU with all the convergence, all the advantages, no repetition of IP addresses in different places, and intent is right in front in the NLRI. That's the right data model. Opaque, putting a global PE address, putting a RD in front of it, and making it a opaque, many things will fail in future. Not just what we have brought up, local convergence, your hack to remove the RD and try to bring them in the single table, then advertise the two routes out because they are unique RD routes. You bring it to
Have you
common
forgotten the
table.
question I asked?
Swadesh, I'm not talking about RD. I'm talking about only the color mapping.
Srihari,
No,
Srihari,
I'm
can
just
I?
trying to compare. I'm just
Srihari,
trying to
Swadesh,
compare. Mhm.
Srihari, Swadesh, can I interject, please?
Sure.
Swadesh, can you please answer Srihari's question where he feels the debuggability amongst one of the many things is concerned? That would
No,
help
they
him answer the
debug.
question.
So, Kairo, I have already
Specifically
answered.
in the multicolor case.
Yeah, I've
Yes,
already
thank you, Pierre.
I explicitly answered already that once you cross the a single color domain crossed, it's a LCM. You see the LCM and you know what is the color of the what is the effective color of the transport.
Thank you.
There's nothing to be doubt there.
And you also make a point that this is a remote case or a rare case of color mapping between providers is
So
a rare
Srihari,
case.
again I'll repeat, we are talking about a network which is managed by an administrator, right? Single administrator. We all agree on that. It's a transport network we're talking about at this moment, and it's operated by a single administrator. So single color domain would be the most frequent case. In the rare scenario, BGP card takes care of it.
So
But we
I'm
have
going to request
optimized the
this.
protocol for
I'm
this
only
scenario.
questioning, Swadesh, I'm only questioning you. You're making a statement that this is a rare case, rather than
No,
believing you.
I'm not. I'm
I want
saying
to hear
okay.
from other operators.
Why I highlight that point is we don't want to penalize the BGP LU advantages just for some percentage of cases where multiple color domains will come. We don't want to penalize that, and that's what
Yeah,
you guys have been
I,
approaching, but we don't want to
yes.
approach that way. And
Okay,
but
No,
I
we
must
have a
stop this.
solution which is clear.
I must stop this
Okay.
question.
Sure.
We have limited time left. We are going to be colliding within the room, so we're going to continue for another 6 minutes at most. So Srihari, please take your question to the list in detail, and let's actually resolve this since we do seem to be coming back to it. Ketan, you have the mic.
Thank you, Jeff. Ketan Talaulikar. I have put this in the chat, but I wanted to bring it on the mic as well because there is debate on the NLRI design of the car and why encapsulation information is being put there, and this is done to support signaling of multiple encapsulations. Uh, we heard today from the city authors, Kalairaj, that a similar or a different, they have, I mean, there is a proposal to how to do that as well in the city proposal. So I would request if, that information is added into the city proposal so that, right now it just comes across like an MPLS only solution. If it is multi-encapsulation, if that detail is added, then perhaps the working group has fair apple to apple comparison of what's the complexity and what's going on there. That's all.
Thank you, Ketan. Tarek, you have the microphone.
Saad with Juniper. Today, the PCE can cater or service a request for for an intent identified by color, and it can compute an interdomain path across multiple IGP domains, for example. And each IGP domain can have different representation of what algorithm ID, for example, they want to implement in their domain. But still, the PCE can do interdomain across different algorithm IDs. There is no mandate to have the same algorithm ID across multiple domains. If I understand correctly, for CAR to work correctly, you have to have the same color because it's part of the prefix NLRI key. And that's a limitation.
Swadesh, you have a brief moment to make a response.
Yeah, again the same repetition. What I already mentioned to Srihari, that for car to work, there is no requirement to have the same color. We support multiple color multiple ways to represent the color or different values to represent the color. But again, I will repeat, we are talking about a single administrator managing it, and this is about inter-domain BGP routing solution. So if you want to carry the intent, you have to carry intent somewhere. In car, we prefer to carry in the NLRI for the most useful cases or most optimized cases. Otherwise, it's in LCM for multiple color domains. And same way, CT can speak for it, but that exactly also carries in the TC. I don't think there's any confusion about this, Sal.
Okay, so we'll take this as one of our questions list. There's obviously differences of opinion, and I think this is why we keep seeing the conversation come back about what a color domain is. Again, let's take it to the list. Kaliraj, we don't have time. Ben, you have the last question.
So speaking as an operator on this question of the complexity of managing color mappings, this is a problem that any kind of interdomain SLA aware service has. Sometimes you're managing mappings of traffic classes, sometimes it's DSCP values, sometimes it's communities, in this case it's colors. And the nightmare part of that is the coordination. Once you've actually done the coordination, you've agreed on a mapping, scraping it off the screen of a CLI is not the complexity. It's a complete red herring. It's not a big deal. The main thing I wanted to just raise, in case it hasn't kind of come across either sets of authors as a use case for this, is fortunately I don't provide interdomain SLA-aware services, but what I do need is a solution to the problem of providing local repair for egress peer engineering BGP routes. And I think that probably both drafts can provide a solution to that. The idea essentially being advertising a unique LU label depending on what the potential backup path is, so that you don't have to fall back to IP forwarding in the event of a local failure. It would be nice to see either in the draft or maybe when we next speak about this at 114 to hear a bit about whether the authors think that that's a good use case and how that might work in practice.
Ben, may I suggest you something? Will you please send those comments to the list? Because I think I heard you say, hey, look, debuggability is not a big issue, but you really want to worry about fast convergence. The fast convergence has to minimally, meaning egress peer engineering has to be minimally taken care of.
Yeah.
And
well, it's clearly not the primary use case, but it is a use case for the ability to have multiple prefix to label mappings.
Absolutely.
Which is one of the things that this provides.
I think sending a note to mailing list would be great.
I will.
Thank you. Over to you, Jeff.
Thank you. This ends our session for IETF 113. We've had, again, good discussion that unfortunately, again, got compressed a little bit. What we'll be doing as part of collecting the minutes is trying to summarize the questions and points where people seem to be in disagreement. And we'll be feeding those questions back to the list in some form for summary. As part of those questions, the chairs will discuss at our next gathering whether we should try to front load potentially another intro meeting to do this, or do we just wait for 114? Meanwhile, since the room has to be released to the next session, thank you for showing up, and we will talk to you all soon.
Yes, we will also have a session on Friday. We have the early session. Thank you.
Thank you. Bye. Oh.